Good morning, everybody. So I thought I'd do a little live stream now just to sort of discuss a point that I've been thinking about sort of last night quite a bit and this morning a little bit. And this point is that I think I think we're certainly going to find life in the galaxy at some point, or in the rest of the galaxy at some point. I think that's very, very likely. I think it's highly unlikely that we're not going to discover at least microbial life somewhere else in the galaxy. Got the James Webb Space Telescope now in orbit. That'll be soon analysing the atmospheres of exoplanets in different solar systems and so on. But more crucially than this, I think it's actually, and the more I think about this, the more I think it's really rather likely that we're going to discover life within the solar system in the form probably of microbes. Um, in the form, yeah, very likely, I think, in microbial form, very possibly, maybe in the form of very small animals. I think possibly, and small plant life, things like algae, you know. Um, and I don't think we're so likely to find life on Mars. And I think if life on Mars is going to be anywhere on Mars, it's probably going to be sort of somewhere near its ice caps and not really on the harsh, barren plains of Mars. And you see these sort of geographic features on the surface of Mars, such as alluvial fans and so on, traces of where there used to be running water on Mars. And there's a certain water content in Martian soil also. And yeah, that's quite interesting, I think. But I don't think it's quite as interesting as what we're likely to find further out in the solar system, particularly around Jupiter, or particularly on the moons of Jupiter, on certain moons of Jupiter. The moon specifically Europa, which is thought to be this incredibly smooth surfaced moon containing a liquid ocean, an ocean of liquid water, of salt water, almost certainly. But we know life can survive in salt water, obviously. So, water being the stuff of life, very, very interesting. But I think a little bit more interesting than Europa. Because yeah, Europa is sort of getting all the press really, and it has got all the press in the past. I think Ganymede, Jupiter's largest moon, is likely to be a bit more interesting than Europa, because I hope I'm not bungling this one too much, because Ganymede, as I understand it, has a rocky surface. So, or does it? Or is it an ice surface? And then it has layers under which there are liquid oceans. So it seems like mineral content of Ganymede is likely to be much higher, I think. So Ganymede, a satellite of Jupiter, is the largest, most massive of the solar system's moons, the ninth largest object in the solar system. It's the largest without a substantial atmosphere. Okay, I'm going to go to the Wikipedia page for Ganymede just quickly because I want to remind myself of what's underneath its surface. Okay, so its surface is rocky, I'm pretty certain. It's 26% larger than the planet Mercury by volume, although it's only 45% as massive. Possessing a metallic core, it has the lowest moment of inertia factor of any solid body in the solar system and is the only moon known to have a magnetic field. Out from Jupiter is the seventh satellite and the third of the Galilean moons, the first group of objects discovered orbiting another planet. Ganymede orbits Jupiter in roughly 7 days and is in a 1, 2, 4 orbital resonance with moons Europa and Io, respectively. Io is also very interesting. Io has volcanoes and things. And we know that certain forms of extremophilic bacteria thrive in places like volcanic vents underwater. So that may also be an interesting place to look for life in the solar system. What I want to know about its subterranean characteristics. Here we go. Ganymede is composed of approximately equal amounts of silicate rock and water. It is a fully differentiated body with an iron-rich liquid core and an internal ocean that may contain more water than all of Earth's oceans combined. Its surface is composed of two main types of terrain: dark regions saturated with impact craters and dated 4 billion years ago, cover about a third of it. Lighter regions cross-cut by extensive grooves and ridges and only slightly less ancient, cover the remainder. The cause of the light terrain's disrupted geology is not fully known. It's likely the result of tectonic activity due to tidal heating. Ganymede's magnetic field is probably created by convection within its liquid iron core. Liquid iron core. This is a fascinating planet. I don't think Europa is nearly as interesting as Ganymede. This liquid iron core also created by Jupiter's tidal forces. The meager magnetic field is buried within Jupiter's far larger magnetic field and would show only as a local perturbation of the field lines. Ganymede has a thin oxygen atmosphere that includes ozone and O2, and O3 and possibly O3 is ozone, right? Monoatomic oxygen. Sorry, I always get those mixed up. Atomic hydrogen is a minor atmospheric constituent. Whether Ganymede has an ionosphere associated with its atmosphere is unresolved. Ganymede's discovery is credited to Galileo Galilei, who first observed it on 7th of January 1610. Its name was soon suggested by astronomer Simon Marius after the mythological Ganymede, Trojan prince desired by Zeus, lol, of Greeks. Yeah, everyone was sort of bi in ancient Greece. The Greek counterpart of Jupiter, who carried him off to be the cupbearer of the gods. Beginning with Pioneer 10, several spacecraft have explored Ganymede. The Voyager probes, Voyager 1 and Voyager 2, refined measurements of its size, while Galileo discovered its underground ocean and magnetic field. The next planned mission to the Jovian system is the European Space Agency's Jupiter Icy Moon Explorer, JUICE. I hate these acronyms. I really do. Oh, carrying Jupiter's juice, friend. Oh, fucking hell. Lol. All after flybys of all three icy Galilean moons, it is planned to enter orbit around Ganymede. I'm going to quickly check out Io as well. Yeah, Io also. That relates to a humorous little story relating to Jupiter and or Zeus, who are the same person basically in Greek mythology and Roman mythology, because Io was this beautiful little nymph, or beautiful nymph, like who Jupiter was sort of courting. So I imagine sort of like I imagine a tall, blonde-looking, beautiful young woman, right? And he's sort of going, "Oh, like, come here, my lovely," and all this sort of thing, and being cantankerous and going after the young nymph. And then his wife comes along, Hera, and he quickly transforms Io into a white heifer, like a young cow. I can just imagine like him with his shoulder on the cow, and Hera comes, "What are you doing with that cow?" And I was like, "Nothing." So yeah, as part of Ovid's Metamorphoses, are kind of a funny little story, and probably raise a few yucks back in ancient Greece. Where is the link to Io on this page? I saw it a moment ago. Where is it? Oh, I can't be bothered. Just type in Io. Io moon. Innermost, the third largest of the four Galilean moons of the planet Jupiter, slightly larger than Earth's moon. Io is the fourth largest moon in the solar system, has a high density of any moon, strongest surface gravity of any moon, and the lowest amount of water. It doesn't have much water. Priestess of Hero became one of named of mythological character. Iron Priestess of Hero became one of Zeus's lovers. With over 400 active volcanoes, Io is the most geologically active object in the solar system. This extreme geologic activity is related to tidal heating from friction generated within Io's interior as it's pulled between Jupiter and the other Galilean moons, Europa, Ganymede, and Callisto. Several volcanoes produced plumes of sulfur and sulfur dioxide. It's actually pretty hostile to life from what I can see. Silicate rock. Yeah, I think life is actually pretty unlikely to exist there. So look at Callisto. I think I know enough about Europa, perhaps. Callisto, Jupiter 4, second largest moon of Jupiter after Ganymede, third largest moon of the solar system after Ganymede, and Saturn's moon Titan. Largest moon in the solar system may not be properly differentiated. Callisto was discovered in 1610 by Galileo Galilei. 99% of the time it's the planet Mercury, but only a third of its mass. Does it contain water? It is composed of approximately equal amounts of rock and ices and density at 1.3 grams per 1.83 grams per cubic centimeter of lowest density and surface gravity of Jupiter's major moons. Compounds detected spectroscopically on the surface include water, ice, carbon dioxide, silicates, and organic compounds. Organic compounds. And possibly subsurface ocean of liquid water depths greater than 100 kilometers. Very cool. So, in order of likelihood, I think the most likely places to find life in the solar system probably Ganymede, Europa, Callisto, then maybe Europa. Titan, I think that's very likely, if I'm brutally honest. I think it's even though it's got a very thick atmosphere, that atmosphere is formed largely or exclusively possibly of hydrocarbons, whereas atmosphere is mostly methane. I don't think that methane, like to some extent in an atmosphere, is associated with life, as also is carbon dioxide. But I don't know. That was so is oxygen, and yeah, oxygen on Ganymede in its atmosphere has got O2, O, and ozone possibly. Like little algae, photosynthesizing and emitting oxygen. And it has a very small amount of carbon dioxide. In any case, yeah, very cool. I think those are probably the places where we're most likely to find life in the solar system. So, as I've also said before, we need to get on with the processing of large hemp crops into composite thermoplastics made with hemp plastics, which have a tensile strength of 1,110 megapascals, as opposed to carbon steel that has a tensile strength of 864 megapascals. So the implication there is we could certainly use those thermoplastics, and those are plastics after all. Hence, they're more than ductile enough to build spacecraft out of, and certainly ductile enough to build skyscrapers out of. And buildings like the Burj Khalifa in the Emirates, Dubai, those probably represent about as big as a building can get using steel. I reckon if you're using hemp plastic, you could get a much taller skyscraper. And I also suspect using hemp thermoplastic composites, one could build a rocket that's the size of a skyscraper, because hemp plastic is about as light as carbon fiber also. But you can't really use carbon fiber to make rockets because carbon fiber is too stiff and it doesn't bend, whereas plastics obviously do bend. In fact, like the ductility of hemp plastic, I imagine, is probably better than that of steel. So, like a big skyscraper, right, needs to bend in the wind like about 8 meters, or is it 8 feet? I think it might be 8 meters. I think that's how much the Empire State Building is designed to sway in the wind, isn't it? And the Burj Khalifa needs to bend even more than that. I'm not talking really about building a rocket the size of the Burj Khalifa. Not yet, anyway. Not for a while. But I mean, a rocket the size of the Gherkin? A rocket the size of the Empire State Building? I reckon we'll do that one day. I think we will. I think once we figure that out, it'll become the far more economical solution to getting really large ships in space than a space elevator. I don't think you could really try to build a space elevator without having that technology first, unless you were to do it using thousands and thousands of rocket launches. Because to build a space elevator, you need to get, I think it's something like 100,000 kilometers of very, very high strength cable into space to even begin thinking about operating a space elevator. And I think like space elevators like would I think it might well happen one day. I don't. It might not even be necessary. It might be an unnecessarily big project to do that. It might not. It might not be. I mean, you can land rocket stages now. You can only like land the first stage of the rocket, though. What really needs to happen is what Elon Musk ultimately wants to happen in that regard, which is yeah, landing the first stage, but having the first stage weight suspended in the atmosphere, high in the atmosphere, allow the second stage to come back through the atmosphere, connect with stage one, and then allowing the stage three, the payload stage, if you like, to also have attached to stage two and for it to reverse back down and land again. And that will be necessary if he wants to take people on and off of Mars. But then he's talking about like doing other things like 3D printing space stations, and that will expedite, that will help a great deal with the process of, you know, making or facilitating the exchanges of larger and larger payloads in space. But I mean, if we had these hemp thermoplastics, I maybe the sky's the limit, really. When it, you know, no pun intended, and the sky in practice probably isn't the limit. Granted, um, and that in spite of a tensile strength of 1,110 megapascals, like you still can't build a rocket all the way up to the end of the sky. I don't think you could. Um, but yeah, a rocket the size of a skyscraper, I think that is possible. And like, not to be too science fictiony about it, but mm, yeah. So I mean, the Starship is like, it's not really the size of a skyscraper. It's about the size of the Statue of Liberty, but which is kind of titch compared to most skyscrapers. I so want to see something like that. Oh my goodness me, that'd be amazing to see. Skyscraper sized rocket. Bonus points. Obviously, if it's 3D printed in huge warehouses, we call it ateliers instead of factories, and I don't know, like a shift in the culture, something towards very great amounts of progress indeed. And yeah, manned missions to Jupiter then would become far more possible. There's additional advantages to using things like plastic in the construction of spacecraft, such as the shielding from radiation. That's a big one. But I'm tempted to say, like, probably the best way to shield from solar radiation is actually not to go to Mars and not really to go anywhere without a magnetic field. And if you're to go sort of between the Earth, say, and somewhere like Jupiter that has a magnetic field, a very strong magnetic field, you want to get between your Earth magnetic field and your Jupiter magnetic field just as quickly as possible, using the best shielding available to you. And as long as you're going pretty fast, like that sort of mitigates the amount of particles you interact with. I think, well, it limits the amount of exposure time to those particles. And granted, actually, it probably doesn't limit, strictly speaking, the precise number of particles that you do interact with. But if you're going really quite quickly, you know, you do have like these sort of length contraction, I think, effects. You can sort of see like more quantum effects building up. I think it mitigates the possibility that any particles would be interacting with your craft, and hence limits the damage you're exposing your astronauts to. But then again, it might actually just like, would it fry the astronauts in there? Like, you have to like run the experiment on like a sausage on on a sausage or something. Like fly a sausage to Jupiter at like 50 millimeters per second or something. Get it to slingshot back and see how cooked the sausage is. So, like, there you go, astronauts. We ran the test on a sausage. Like, came back intact or like uncooked. Like, therefore, like, where you go, chaps and ladies. So yeah, I don't think going to Mars is like a particularly good idea. It's very hostile. It doesn't have a magnetic field. It's it's the cosmic ray radiation. I wonder like what cosmic radiation levels are on Mars exactly. I bet they're pretty not nice. Cosmic ray radiation Mars. Objects with high dose of cosmic radiation consist of highly energetic particles and multiple types of ionizing radiation. The dose can increase temporarily by a factor of 50 through the occurrence of highly energetic solar flares. Mm. Compared to Earth's atmosphere, the thin Martian atmosphere is a less powerful shield against quick-moving energetic particles that pelt from all directions, because astronauts on Mars will need protection from this harsh radiation environment. Well, yeah, that's the major concern, isn't it? Like, why are you going on Mars? You don't like punish people by sending them to fucking Mars. I've never thought that was a good idea. Still using gamma rays to radioactive cobalt, even though the actual cosmic radiation on Mars, so something. Mm. I mean, when the astronauts we sent to the moon were shot through the Van Allen radiation belts, which are these radiation belts in Earth's magnetic field that shield us from all the incoming solar ray particles from the sun and trap them there. These protons and electrons, basically, sort of unbound. Uh, it's they they were just pelted through it quite quickly, so their exposure time to the radiation was pretty minimal. As you're calculated on that basis because how fast was the Apollo spacecraft moving? Very very fast, I think. Speed of Apollo 11 on way to moon. Here we go. 2,040 miles per hour. Not as fast as I thought it would be. Hmm. Yeah. But then again, cosmic ray particles, those are alpha and beta particles. Those don't actually cause you so much damage unless they're inside your body, being released from within you. This is why, oh God, what's his name? Alexander Litvinenko, this former Russian spy who was blatantly poisoned by Putin. That's why he succumbed to poisoning by polonium, because that was released. That's an alpha source. That's releasing basically protons. Is emitting alpha protons inside his body. If it's like releasing protons outside your body, you're relatively well shielded from it anyway by your skin. So alpha sources of radiation, they're not actually that harmful to you. Neither are electrons, free electrons, no matter how fast they're traveling. So, I mean, dangers of cosmic rays. Dangers of cosmic rays. Again, I suppose it depends on how many cosmic rays there are. Beyond low of radiation sickness and increased lifetime risk for cancer, central nervous system effects, and degenerative diseases. Mm. This is not what I was taught in physics, though. Cosmic rays, though, can only be seen by detectors such as the spark chamber all about us. Indeed, if it takes several minutes to read this page and several hundred cosmic rays, will pass through your head and penetrate into your body. The question, therefore, which must be asked is, are cosmic rays harmful to humans? Mm. Mm. I'll have to read up more on this, I think. But yeah, generally, I think Jupiter slash the moons of Jupiter is really where we want to be going because of Jupiter's magnetic field. So it's like a safety, a safe little zone, isn't it? Where it's shielded from radiation. And Mars, like, fuck Mars, don't want to go there. Silly idea. Thanks everyone for watching. Bye bye. Love you lots.